This video is going to walk you through the predator-prey dynamics simulation. This simulation includes an example of a system model. Instead of having you system model, I'm asking you to do a causal loop diagram. So what this video is going to do is going to take that system model and it's going to kind of work backwards and build the causal loop diagram. And it's going to walk you through kind of how these two things relate to each other. So when you open up the simulation, it has your background and it has your context, and then it has your spot to explore your model, and you're going to click on Take a Guided Tour. And so the first thing that comes up with the model is the fact that we have a hare population, and we have two factors affecting that hare population, and that's hare births and hare deaths. So remember, in a causal loop diagram, we just simply write these variables down. If we have more hare births, then that's going to cause a change in our hare population. Our hare population will also go up, so we're going to put a plus there. Now, our other variable, hare deaths. Remember that hare deaths is going to have an effect on the hare population. If we have more rabbits dying, then we're going to have a smaller population, so we're going to put a minus sign there. If our population is bigger, that means we have more rabbits to die, so we're going to have a plus sign there for hare deaths. Next, I'm going to hit the space bar in our simulation, and it's going to show us our next relationship. That is, if our hare population increases, we're going to have more births because there's more rabbits to reproduce with each other. So we're going to put a plus sign there. The next part of our model adds the links into it. So I'm going to add our links population into my causal loop diagram. In our system model, it's a red. I'm going to use orange here. And our relationship shown in the system model is that if we have more links, if we have a bigger links population, then that's going to lead to more hare deaths. So we're going to symbolize that by an arrow with a plus sign. Remember in our causal loop diagram that a plus means that two variables are directly related to each other. If one goes up, the other one's going to go up. If one goes down, the other one's going to go down. Remember that a minus means two variables are inversely related to each other. If one goes up, the other one goes down. As I continue on with my model, I notice that it gives us two more variables. We have hare density, and we have the number of hare killed by our links. Remember, density is just how much is packed in one area. So hare density is how many rabbits actually live in a small area. If we have a bigger population, then our density is going to increase. We're going to have more rabbits living in the same area. If we have more rabbits, it's going to be easier for our lynx to hunt. So that means we're going to have more rabbits killed by our lynx. If we have more rabbits killed by our lynx, that means we're going to have more deaths. So all of these are direct relationships. One goes up, the other one goes up. So they're symbolized all by a plus when I draw my arrows. I continue on with my model. The next thing it reminds us is that our lynx population is affected by our lynx births. If we have more births, then we're going to have a bigger population. So there's a plus. If our population is bigger, that means there's more lynx to reproduce. So I'm also going to draw an arrow there with a plus. The last part of our model has lynx death. And lynx death is related directly to our population. If I have more deaths, I'm going to have a smaller population size. If I have a bigger population size, I have more lynx to die, so I'm going to have more lynx. My hare density decreases. It's going to be harder for the lynx to hunt, so that means that I'm going to increase my number of deaths. So I'm going to have a minus there.